Hello, young math Padawans. It's Mrs. Angel with your lesson for today on when are ratios proportional. First, let's start with what's proportional mean? Proportional means we have ratios that are equivalent. We've talked about equivalent before. Equivalent means that have the same value. Now, all the ratios that we're looking at in this video are in the fraction form, and we're going to determine whether or not they are proportional in three strategies. Strategy 1, we're going to simplify both. Strategy 2, we're going to find common denominators. And strategy 3, we're going to use something called a cross product. So let's get started. Strategy 1, we're going to put both ratios in simplest form. And if they're equal, they're proportional. If they're not equal, they're not proportional. Let's look over here at example 1. So to simplify both fractions, we need to find the greatest common factor of both. So I know that the greatest common factor, or GCF, of 4 and 8 is 4. And I know the greatest common factor, or GCF, of 3 and 6 is 3. So let's go ahead and simplify both. 4 is 4 times 1, and I know 8 is 4 times 2. So I'm factoring out that GCF in the first fraction. In the second ratio fraction, we have GCF 3. 3 times 1 is 3, and 3 times 2 is 6. Now that we've factored out the greatest common factors, we have some big 1 factors. And it looks like our first ratio in simplest form would be 1 over 2 or 1/2. Second ratio in simplest form, also 1 over 2 or 1/2. Are those equal? Yes. Therefore, we would say that these ratios are proportional. And it's as simple as that. So since I already know you know how to simplify fractions, why don't you do example 2 and example 3 on your own now? Let's see how you did. In example 2 here, the fraction 12 to 9 in simplest form is 4 to 3. And 6 to 8 in simplest form is 3 to 4. Those ratios are not the same. They do not represent the same value. Therefore, these were not proportional. And over here in example 3, the simplest form of 10 to 15 was 2 to 3. And the simplest form of 8 to 32 was 9 to 16. Definitely not equal, which means definitely not proportional. Now, simplifying is great, but it's not the most efficient method we have. So that brings us to strategy 2. Strategy 2 is to find a common denominator because, again, similar to strategy 1, if both ratios have the same denominator, we can tell whether or not both ratios are equal. So let's take a look at example 1. We have 4 to 6 and 10 to 15. So what common denominator works for 6 and 15? They both go into 30. So I know I'm going to set up equivalent ratios out of 30 this time. And I'm going to use big ones to do so. So to get 6 to 30, I know I'm going to multiply by 5/5. So that's 20 to 30 as an equivalent ratio. And to get 15 to 30, I'm going to multiply by 2/2. So that's 20 to 30 as an equivalent ratio. Look at that. They are equal. Therefore, these ratios are proportional. Since I know you've found common denominators before in the past, why don't you go ahead and do example 2 and example 3 on your own now? How'd you do? Well, for example 2, I found a common denominator of 12, and 9 to 12 is definitely not equal to 8 to 12. So these were not proportional. In example 3 here, I found a common denominator of 72, and 108 to 72 is definitely not equal to 120 to 72. Therefore, again, these ratios are not proportional. Again, common denominators are great, but it's not the most efficient method. That brings us to strategy 3. Strategy 3 is called using a cross product. Let's take a look at what that looks like with example 1. Here's how a cross product works. We're going to take our numerator of our first ratio 9, and we're going to multiply it across to the denominator of our other ratio 4. So over here on the right side, we're going to multiply 9 times 4. Now, we're going to do the same thing with our other numerator and denominator. We're going to take the numerator 18 and multiply it by the denominator 2. 18 times 2. Now, these are called cross products because we're multiplying across. If they're equal to each other, the ratios are proportional. And if they're not equal to each other, not proportional. So let's simplify. 18 times 2, well, that's 36. And 9 times 4 is also 36. Last time I checked, 36 equals 36. So since the cross products are equal, we can say that the ratios are proportional. Now this might be the first time you've seen that, so let's go over example 2 really quick together again. Cross product. Take the numerator of one, multiply by the denominator of the other. So that's 6 times 6. Numerator 4 times denominator 8, 4 times 8. Let's see if they're equal. 4 times 8, that's 32. 6 times 6, that's 36. Does 32 equal 36? No way. Therefore, because the cross products are not equal, we would say that these ratios are not proportional. So it's your turn. Go ahead and try example 3 on your own now. Did you like dealing with the decimal? Well, if you did all of your math correctly, 6 does equal 6. The cross products are equal, therefore these ratios are proportional. The best part about cross products is they can be used to solve proportions. So if you look at all 3 of these proportions, part of them are missing. And the difference now is that I'm saying and telling you that they're equal. The ratio should be equal. Now you have to find the missing piece. So let's take a look at how a cross product can do that in example 1. All right, it'll make it easier if I replace the unknown question mark with a variable. So I'm just going to replace this with the variable x for now. Let's set up our cross product. Numerator 10 times denominator 6 and numerator x times denominator 2. Now we know that these ratios are proportional. The equal sign was already there, so we're going to bring that equal sign down because if they're proportional, their cross products are equal. Let's simplify. X times 2, well, we're just going to write that as 2x, and 10 times 6 is 60. Now, how do we solve for x? Well, you could use some mental math. 2 times what is 60? Or you could use inverse operations. The opposite of multiply is divide. So if I'm multiplying my unknown number by 2, then I can go in there and undo that by dividing by 2. And guess what? That just makes a big 1, which we've definitely seen before. And I'm left with x equals 30. So what did I just find? I basically just showed that my missing value here should be 30. And if it is, then the ratios are proportional. But I don't know for sure until I check. So to do a check, I'm going to rewrite both ratios, 10 to 2 and 30 to 6. And now it's a question. Are they proportional? Now I can go back to my 3 strategies. I can simplify both, I can find a common denominator, or I can do a cross product. Since I already did the cross product, I might as well just do it again, just to be sure. So here we go. 10 times 6, that's 60. 30 times 2, also 60. And last time I checked, 60 equals 60, which means I found the correct missing value in our ratio. Now that was kind of a lot, so why don't we try doing example 2 together right now. I went ahead and covered up the unknown value with x. Let's set up our cross products. Starting with 10 times 9. All right, and we have 4 times x. Now 4 times x, we're just going to write that as 4x. And 10 times 9, that's 90. How do we solve this equation again? That's right, the inverse or opposite of multiply is to divide. So we're going to divide both sides by 4. That creates one of those big ones we're so used to. And x equals 22.5. Wait, can our answer be a decimal? I think so. Let's find out and see in our check. So we're going to set up our 2 ratios. We have 10 over, well, we think it might be 22.5. I don't know. And is that equal to our original ratio of 4 to 9? Let's use a cross product and check. Let's see. I know 10 times 9, well, that's 90. And 4 times 22.5, it's okay if you grab a calculator to check, but you can take my word for it, that's also 90. So since those are equal, we know that our missing number in our proportion was 22.5. So now that you've seen 2, it's time for you to do 1. Go ahead and try example 3 on your own. Let's see how you did. 4 times x is just 4x. And 5 times 6 is 30. Divide both sides by 4, and I got 7.5 or 7.5. I did do a cross product, and they are equal, so my missing value in my ratio was 7.5 or 7.5. So to quickly summarize, two ratios are proportional if they are equivalent. And the best way to test that is a cross product, especially when you have to solve for one of the missing parts of a ratio. That's it for today's lesson. We'll see you next time.